Okay, so basically what we're trying to do would be something like you have 100 feet of fence for your garden. What is the biggest possible garden you can have? Okay, that would be a good question to answer here, right? Let's actually calculate that out because it's something that I did for my garden.
Really? Is that high?
So you have a perimeter and you want to maximize area, right? Okay, so the first step is to identify your equations. Maybe. Okay, what's the perimeter equation? Yeah, 2L2W, 2X2Y, take your pick, right? I use X and Y because that's what we're used to using in derivatives. Just makes it a touch easier. And area is X times Y, right? Okay, we know what the perimeter is, right? Pay attention here because they're not easy. Okay, take your pick. Solving for X or Y? Okay. So here's X in terms of Y. Bless you. Now I'm going to plug that in here. And simplify it because it'll make it easier. You following me? Okay, I'm a bro now. Sweet. Now take the derivative. Can we continue now? Yeah. Thank you. Okay. What are we looking for when we take the derivative? What happens at a maximum? Critical point, and we need to set it equal to 0.
So we use the critical point.
Yep. Y is 25.
So then we plug it back in,
Plug it in.
into the original. Yeah.
You just slide down and have it. Okay, there we go.
Yep. 100 equals 2x plus 2 times 25.
That was like super complicated, just like the easy, like.
It is an easy problem. Yes.
Does it get like more complicated though?
Uh-huh. Surface area and volume. So basically, you're learning the process here. I know it's one you can do just by guess and check, but so the garden is how big?
25 and 25.
Okay. So let's sum up. We first wrote our equations out, right? The first equation there's a vocab word for it.
Shoot me that vocabulary.
It's called a constraint equation.
Wait, for what is constraint equation?
This gives you your x and your constraint here. So that's what this is.
Oh, like the beginning.
It tells you how y and x are related. Okay. This is called the objective function. Okay, so that's the one we want. That's our objective. We want to maximize that function. So those two words will pop up. Okay. The constraint is the one you're given the number for. The objective is the one you're trying to differentiate, maximize, minimize, etc.
Wait, so objective is what is maximize?
Yeah, we maximize
Oh,
this.
so you want the maximum area? Okay.
Yeah,
So if you had a volume and said what's maximum surface area, then that would be the
the
objective.
surface area would be the objective function.
Okay.
Yeah, which I'm actually going to show you. So we solved for x, plugged it in, differentiated. I'll call that 3, 4. Found our critical point and finished it off. So there are quite a few steps in these. All right, can we move on? All right, let's do that surface area and volume.
You're gonna let the constraint and objective equation. Yeah.
Okay, let's say we have a cylinder that's 900 cubic centimeters.
So we're going to design a can that uses the least amount of material for it. Right? So we have the volume is our, which one is it, constraint or objective? It's the constraint, okay. And that is power squared H for a cylinder. So we're going to set 900 equal to that. What's our objective? Okay, it can get a little messy. All right. So we're going to use this. We need to solve for R or H.
Let's solve for R.
No, H. Let's do the H. Yeah.
Oh, never mind, yeah, H.
All right. Right? Okay, so this here relates R and H so that we can plug it in. Put it in there. Now we're in terms of R, the whole thing. It's easy to take a derivative once we're going to simplify this a little bit. We aren't going to have implicit differentiation haunting us. Okay, that's the nice thing about doing this. Okay, now what do we do? Yep. You okay with the derivative? It's R to the negative 1, right? 1800 R to the negative 1. So use the power rule. So bring down the negative 1, subtract 1. So it becomes R to the negative 2. Okay. And now set it equal to 0. No.
It's the 13. Oh my god. Yes. You just said something. Oh, I love that. You know my grandma when she like smokes a cigarette?
Yeah, that's
It's so awkward in her face. Oh, thanks.
Would you ever have guessed that was the best R value?
Nope.
No, probably not.
Oh,
Now, this is a real world problem where we want to put it in terms of decimals, right? Because it's pretty loud last hour. I know. We about had a techno light switch rave in here. It was awesome. What decimal value does that give us? Oh, really?
part of the calculus. Yeah.
Oh, plug into the original equation, right? It's 5.232. 5.232.
And then plug it back in, right?
Yeah. Wait, you plug it in as, oh, always R.
It doesn't matter which one you use.
Oh. Should we plug that one back in the original? And find it?
Yes.
It turns up.
I want to go watch this right now. So,
Then you gotta see
can we
it.
take a class road trip real quick?
No.
So we can just put it on here.
Only if you can re-explain how to do this.
Okay, Ben, explain it now. Oh, Ben, oh, you got it.
And you know how to explain that, so what you're gonna do is you're gonna
Oh,
start
yeah.
out with your constraint equation, and then you're gonna have your objective equation. Your constraint equation, they give you the volume, so
Go. Keep going.
they're gonna plug the volume, you're gonna take the volume to 900 centimeters cubed. So you plug that into the constraint equation, you get 900 equals pi r squared h. And then you rearrange for h. And you plug that into the objective equation.
Finally, Ben, keep going.
You simplify. And you simplify and then you differentiate for surface area. And you get 4 pi r minus 1800 over r squared. And you set that equal to 0. And you get 0 equals the same thing. Yeah.
Why do we set equal 0?
You're trying to find the circle points.
Right.
Then you solve for r, and you find it in numeric form, because that you don't want to have that, say, cube root of that and that. And then what you're gonna do is you're gonna plug it back into your constraint equation, and that's where we're at right now. So give me a second, and we're gonna rearrange for the thing that when we solved for h before, we're going to plug the r into that, and then that's going to give it.
Either or. It doesn't matter.
It
No.
is so good!
It said if
When we're done, we'll watch it. Thanks, Ben. Okay, are you guys clear on those?
yeah.
You think you can handle a couple of them?
Yeah.
Okay.
Oh wait, what is h?
H 10.46. So here's the size of our can. Do you guys think that Monster and Red Bull and Coca-Cola actually use those? Yeah, they do actually. When you produce 1 million units of something, 1/100th of a square centimeter of stainless steel ends up being a lot of stainless steel. You can save a lot of money and increase your profits by using this stuff. Okay? Okay, I'll keep that in mind when I'm an accountant, right?
Hey, can we do a project with this?
That, I will not gonna lie, though, that would be
Like, like a handful of tin, tell us like that's tough. And then we should do
Yeah, that's a good idea.
a project. I'd rather do a project.
I would like to.
I would like to do a tin project.
That water bottle was $4. The gallon was 91
Okay, that's quite a bit of work, but it's not due until Friday.
Are we gonna get other work added on?
No.
Okay.
So this is what we did today. This is for tomorrow,
What do you mean by grade one?
prelims,
Well, yeah, all that on now.
1.
What is
Prelim number 1, there's prelim problems, we've been doing them. And then the spiral.
It's like those.
What? Is this matching the board?
That should be.